like standard deviation. We have the knowledge on standard deviation, mean deviation, quartile deviation, and range. The four types of measurement of dispersion, right? One is the maximum, most commonly used. There is standard deviation or sigma. Next, quartile deviation. That is QD. Again, there is an mean deviation or MD. And again, there is range. Similarly, for each of that type of dispersion technique, there is corresponding a relative technique for each of them. Like for standard deviation, that is coefficient of SD. There is a relative measurement related coefficient on SD. There is a relative measurement for the standard deviation coefficient of SD. Okay, or the sigma. We know the well-known name sigma. Sigma, right? Number two, the coefficient of QD. QD. Number three, the coefficient of MD. Number four, the coefficient of range. Okay, the four technique used in the to find the relative dispersion. Number one, coefficient of SD or sigma. Number two, coefficient of QD. Number three, coefficient of MD. And number four, coefficient of range. Obviously, the coefficient of SD relates with the standard deviation technique. Coefficient of QD relates with the quartile deviation technique. Coefficient of MD relates with the mean deviation technique. And coefficient of range relates with the range finding technique. Okay, but sometimes this is the best measurement of relative dispersion. It is called as CV or coefficient of variation. Sometimes coefficient of SD is called CV or coefficient of variation. Coefficient of variation. And this is the best measure of, this is the best relative measurement of dispersion, that is coefficient of SD or the CV is the best measure of relative measurement, relative dispersion. Okay, so let us start today the measurement of coefficient of variation. How can we calculate the CV for a particular example? Basically, relative measurement, whatever it may be, coefficient of variation or coefficient of QD or coefficient of MD or coefficient of range. Basically, it compares. Actually, the relative measurement means it compares two set of data, right? Whether it is for the case of coefficient of QD, whether it is for the case of coefficient of MD, whether it is for the case of coefficient of range, whether it is for the case of coefficient of standard deviation. For all cases, basically relative measurement or relative dispersion means actually we compare two separate set of data. Like let us start with an example. How can you compare two set of data using some coefficient of variation technique? We'll go for an example one. The number of runs scored by the cricketer A and B during the test series for each of 10 innings is shown below. That is, for the cricketer A and cricketer B, you have seen there are 10 last 10 innings score is shown here. Last 10 innings score. Now, make an comparative study. I repeat, make an comparative study. You have to compare these two players, these two cricketers, of their batting performance. Make a comparative study of their batting performance. That is, actually we compare their quality, compare their performance of the cricketer A and cricketer B. We compare their batting performance. Whether cricketer A is good with respect to the batting performance, or cricketer B is good with respect to the batting performance. Who will be better? Let us see. There is a slot available in your team, and you have to select anyone, either cricketer A or cricketer B. Who will be your automatic selection? That is, uh, uh, depending on their batting performance, who will be your automatic selection? Whether cricketer A is good with respect to cricketer B, or cricketer B is good with respect to cricketer A. We have to compare their batting performance by using coefficient of variation, or it is called coefficient of standard deviation, or sometimes it is called coefficient of sigma. Now see, solution. We use the coefficient of variation CV to measure the dispersion. We know the meaning of dispersion is data scatteredness. Compare their batting average to make a competitive study on their batting average. We use coefficient of variation to make a comparative study in their batting average. We use coefficient of variation. How can you use that? Another line is written: the batsman with smaller dispersion is more consistent. I repeat, the batsman with smaller dispersion, after calculating the dispersion or calculating the CV, who have the minimum CV is the better batsman with respect to the another. Let us see. Let us see the last line of this example. You see, since for the cricketer B, after calculating, we get, since for the cricketer B, coefficient of variation is smaller, as you see the CV for B. For the cricketer B, the CV is 15.365. Okay. And for cricketer A, the CV is 50.07. And if you compare this 15.65 and 50.07, we see cricketer B has less coefficient of variation in their run score. So the cricketer B is more consistent batsman, is more consistent. Consistent means you can quality batsman, you can say. Cricketer B is as a quality batsman with respect to the batsman B, the batsman A. But that, or you can say, if you have only one slot for your team, you will be cricketer B will be automatic selection with respect, but not cricketer A. Cricketer B will be automatically selected. That is, the coefficient of variation is smaller, he is good quality batsman, and coefficient of variation is greater, he is a bad quality batsman, you can say. But first of all, how can you calculate this coefficient of variation? CV. করে বার করব? To find the CV, actually the formula is CV equal to sigma, or the call is that is called standard deviation by arithmetic mean x bar into 100. For both the two batsmen, we have to calculate the sigma for their run last innings, arithmetic mean for the runs of their last 10 innings, and we have to calculate the CV by using the formula sigma by x bar into 100. Sigma means standard deviation of the runs obtained by cricketer A and cricketer B for the last 10 innings. X bar is the arithmetic mean of the cricketer runs of the cricketer A and cricketer B for the last 10 innings. You have to calculate this sigma and x bar and divide by sigma, divide sigma by x bar, multiply with the 100, we can get the CV. Okay. Now again, you know the formula for arithmetic mean is this. Because there is a simple observation like cricketer A and cricketer B, no frequency involved in this distribution in this frequency distribution table. Only some observations, so that is 10 observations. The innings number 1, cricketer A scored 34, second innings 36, third innings 45, fourth innings 75, and so on. So only simply 10 innings score is given, nothing else. So we have to use the arithmetic mean formula as summation x by number of innings or number of observation, that is 10. And also to calculate the sigma, we use this formula. That is root over x square by n. N means total number of items or total number of observation for this particular example, and n equal to 10 minus summation x by n, like this x bar. You can also write it 10 here. Or others, you can write sigma equal to summation x square by n minus x bar square. X bar mean arithmetic mean, that is calculated by this formula. And we have to find sigma A and also sigma B. A for the calculation for the batting performance of cricketer A, B is for cricketer B. Similarly, mean, we have to find the x bar for the cricketer A is batting average, and x B bar is the batting average of the cricketer B. Okay, now let us see how can we calculate all of this. This is the table for calculation of mean and SD for both player A and B. This part is for player A, left hand side is for player A, right hand side for player B, right? And there is another thing. Actually, we use the change of scale and origin in this for this particular example. আমরা যেহেতু আগের দিন করেছিলাম চেঞ্জ অফ স্কেল সম্বন্ধে কিছু আইডিয়া ছিল, তাই সেই টেকনিকটা এই ক্ষেত্রে আমরা ইউজ করেছি। ইউ মে নট ইউজ দ্যাট, নো টেনশন। স্কেল, চেঞ্জ অফ স্কেল এন্ড চেঞ্জ অফ অরিজিন পরীক্ষায় করতেই হবে এমন করে মাথা ব্যথা নেই। আগেকার দিনে ইউজ করা হতো, নাও এখনকার দিনে খুব একটা ব্যবহার করা হয় না। চেঞ্জ অফ স্কেল এন্ড অরিজিন কিভাবে ব্যবহার করেছি, উই রাইট ওয়াই ইকুয়াল, এটা গল্পে গল্পে বলে দিই, আগের দিনে আমি ব্যাখ্যাও করেছিলাম অনেক। চেঞ্জ অফ স্কেল বা চেঞ্জ অফ অরিজিন বেসিক্যালি উই ইউজ টু minimize the calculation in the table calculation. Basically, I repeat, change of scale or change of origin we actually use to minimize the calculation part. Now we see in this example, we see এটা আবার বলছি এই change of scale is change of scale or change of origin, that is like y is equal to x minus 50. এই ধরনের ইকুয়েশন তুমি পরীক্ষায় করতেও পারো, নাও করতে পারো। ওকে, দেখাই অঙ্কটার ক্ষেত্রে। For example, I mean normal without change of scale or change of origin, we can do like this. For the cricketer A, I have to write x square. Okay, this is for cricketer A. Without using the technique of change of scale and change of origin. And for cricketer B, I can use say x and x square. Okay, and I can easily calculate like this 34, and that is 34 square. Okay, and then cricketer B next innings score which 36. Then I write 36 square. Okay, then 45. Okay, and 45 square, etc. You have to add all these values, like you have to write a total in this here. You have to write total. Okay, so actually you have to find the total of summation x, that is called summation x, and you have to write the total of summation x square. You have to calculate all 10 marks, that is 10 runs, 10 innings run actually, 34, 36, 45, 75 and so on. So 12, 61, 8, 40, 50 এইভাবেও করতে পারি. Similarly for we can use the, for cricketer B we can use 47, you know, 47 and 47 square x square, 38, 38 square. এই পরীক্ষা এইভাবে করা যেতে পারে, no tension. 52 square. Okay, and again you can get the summation like this, summation x for the batsman B, summation x square for the batsman B. এই ক্ষেত্রে এইভাবে আমরা করতেই পারতাম, স্ট্যান্ডার্ড প্রসেস আমরা এতদিন যা শিখেছি, to calculate summation x and summation x square, then you can find the mean as for the x bar. For the cricketer A, summation x bar will be summation x by n. Okay. Summation x by n. For this part, summation x, summation xa, this is summation xb. We can xa, xb. এটা আমরা করতে পারতাম, no tension, it is xa. Similarly, we can also find xb, summation x bar b, and that is simply summation xb by 10, 10 or n, whatever. You can write it 10 also, because number of innings is 10. You got that. But here we use actually, basically, we use the origin of scale concept. A change of scale and change of origin. Basically, we use another variable y. এইভাবে করতে হবে এমন কোনো বাধ্যবাধকতা নেই, আগেই বলছি পরীক্ষায়, আমরা পরীক্ষায় এসেছিল 2007 ওরকম ভাবে করতে পারো যেভাবে আমি দেখাচ্ছিলাম। আর যদি একটু মিনিমাইজ দ্য ক্যালকুলেশন, যদিও আধুনিক যুগে ক্যালকুলেটারই লোকে ইউজ করে বেশি, হাতে পেনে ক্যালকুলেশনটা কম হয়, খুব একটা প্রয়োজন পড়ে না চেঞ্জ অফ স্কেল বা চেঞ্জ অফ অরিজিন করে। বেসিক্যালি উই ইউজ চেঞ্জ অফ অরিজিন অ্যান্ড স্কেল জাস্ট টু মিনিমাইজ দ্য ক্যালকুলেশন। কি করেছি, we use this variable y as x minus 50. কেন x minus 50 করলাম? x, what is x? X হচ্ছে this run scored by cricketer A and cricketer B. Cricketer A ক্ষেত্রে 10 innings run, cricketer B ক্ষেত্রে 10 innings run. Now why I use y equal to x minus 50? We use 50 as this is an approximation selection. You can get an approximate selection. You can write wild guess. How can you get this 50? If you just by getting simple observation, the runs scored by cricketer A 34, 36, 45, 75, 12, 61, 40, 58, 82, 11. On an average, you can blindly you can say the average will be 50. Maybe without calculating you can write it like this. No tension. You can write it also x minus 40. 40 লিখলেও চলবে. You can write it x minus 60. সে লিখলেও চলবে, কোনো অসুবিধা নেই. But never write like this. Y equal to x minus 100. এটা লিখো না. কেন? তাদের লাভের লাভটা কিছু হবে না। আলটিমেটলি হোয়াট ইউ অ্যাকচুয়ালি ক্যালকুলেট, যেটা আমরা অ্যাকচুয়ালি করি ক্যালকুলেশনটা, যে এই অ্যাভারেজটাকে 50 লেখার কারণ একটাই, যাতে উই হ্যাভ ট্রাই টু মিনিমাইজ দ্য ক্যালকুলেটর। কি ক্যালকুলেশন মিনিমাইজ হচ্ছে? আমাদের এক্সাম্পলে এর রানটা হচ্ছে 34, তাই তো? 34 we have to, when we write x square, the 34 will be 34 square, তাই না? If x and x square will be then 34 square, right? But if we convert this x by y as y equal to x minus 50, then 34 will be 34 minus 50, that is minus 60, that is minus 16, and hence we write minus 16, and you convert, then y square is quite easy with respect to this 34 square. এটাই মূল মিনিমাইজ ক্যালকুলেশন, ঠিক আছে? বাট ইফ উই ইউজ দ্য 100 instead of 50, then there is a big problem. y equal to x minus 100 আন্দাজে, মানে অলওয়েজ আমি বলছি না এর জন্য এক্সট্রা ক্যালকুলেশন কিছু করতে হবে, বাট ট্রাই টু গেস, একটা গেস ওয়ার্ক করে ট্রাই টু ফাইন্ড, you can use 50, you can use 40, you can use 60, but not like 0, 10, 100 like this. Simply apply your wild guess, apply your common sense, you can do that. Okay, তো 100 দিও না, 100 দিলে বুঝতে পারছি ক্যালকুলেশনটা, মানে এখানে যদি 100 লিখতে, রেদার ওয়াই ভ্যালুটা অনেক হাই হয়ে যেত। 34 মাইনাস 100 অনেক বড়, তো স্কোয়ারটা অনেক বড় হয়ে যাবে। সুতরাং 100 টাইপ 100 বা 10 এগুলো ইউজ করা সেফ নয়, বেটার নয়। বেটার হচ্ছে ক্যালকুলেশন মিনিমাইজ করার জন্য মিড ভ্যালুকে মাইনাস করো, অ্যাপ্রক্সিমেট মিড ভ্যালু, মানে লাইক 34, 36, 45, 75, 12, 8, 61, 40, 58, 62, 82, 11. Roughly mid value is 50. Roughly, I repeat again. Similarly, for the cricketer B, I use the same technique. Roughly, I assume on an average, the average run is 50 on an average. Maybe if you calculate using the arithmetic mean formula, may not be the exact value is 50, but it looks like almost equal to 50. So the change of scale formula is y equal to x minus 50, or you can write x as x equal to y plus 50. Okay, now from the last day discussion, we know if this is the formula, x bar, the arithmetic mean will be x bar equal to y bar plus 50 for both player A and player B. Remember, that is, you can write xa equal to ya plus 50. You can write also xb equal to yb plus 50 for both two players. Again, from this x is equal to y plus 50, you can write, that is also the formula for change of scale, sigma x equal to sigma y. Again, we can use this both for player A and both for player B. Sigma means standard deviation, both for player A and player B. I just repeat the change of scale formula. If x is equal to a plus by, if you compare a plus by with y plus 50, a হচ্ছে 50, right? and B হচ্ছে 1, right? So sigma x, the formula is sigma x is equal to B into sigma y. Here B is equal to 1, so sigma x is equal to sigma y, right? And similarly for the mean, just আগের দিনের নোটটা একবার একটু রিডিং করে নেবে, যাদের অসুবিধা হচ্ছে এই ক্যালকুলেশনটা বুঝতে অনলাইন মোডে, তারা একটু আগের দিনের ওই ভিডিও লেকচারটা একবার চেক করে নেবে, দেখে নেবে, তাহলে চেঞ্জ অফ স্কেলটা বুঝতে সুবিধা হবে। যাদের এই অনলাইন মোডেতেই এটা খাতা পেনে বোঝানো মুশকিল হয়, তো একটু আগের দিনের ভিডিওটা একটু দেখে নেবে, তাহলে হয়তো সুবিধা হবে বুঝতে। ওকে, নাও so I write it x bar is equal to y bar plus 50 and sigma x is equal to sigma y. Now the calculation is quite easy. For every x you can get y. For the cricketer A, like 34 minus 50 you can get minus 16, 36 minus 50 using this formula you can get minus 14 and so on so on so on. You can get the total number of that is total y, and this is summation y for cricketer A. Again taking square, it is summation y square for cricketer A. Again this is summation y for cricketer B, right? Again this is summation y square for cricketer B. Now we have to calculate mean for the cricketer A. For cricketer A, mean will be y bar plus 50 using this formula. Using this formula, x arithmetic mean for the cricketer A is equal to y bar plus 50, and the y bar is equal to summation y by n. As we know, this is the formula, summation y by 10. 10 is the number of observation, the number of innings. So y bar summation y means minus 46. So I write it minus 46 by 10 plus 50, you can get 45.5, 45.4. Similarly, if you go for sigma for the cricketer A, you know already the formula is summation y square by n minus summation y by n the whole square. The summation y square is calculated by 5376, that is for y, and we write it here 5376 by 10 minus 46 by 10 is already calculated 46 minus 46 10, and you can get by calculating you can get 22.75. Now the CV for the cricketer A by simply sigma by x, that is 22.73 by 45.4 into 100, you can get 50.07. Okay, the same calculation applied for the cricketer B. Same calculation applied for the cricketer B, and we see for cricketer B, and we see for the cricketer B, the arithmetic mean is 45.5 x bar, and sigma x is 7.12. Same method, same technique, just applied for cricketer B. And CV, and hence the CV for the cricketer B will be sigma by x bar into 100, and that is 15.6. Okay, now if you compare these two CV, if we compare these two CV, 50 point, this is for A, and 15.65, this is for B. We see for the cricketer A, coefficient of variation or CV is smaller. That means he is more consistent batsman than cricketer A. He is more consistent batsman than cricketer A. Okay. Although you can see almost they are, although you can see their mean is almost same. For the case of cricketer A, arithmetic mean is 45.44, ক্লিয়ার? অ্যাভারেজ রান দেখেন, আমরা সবসময় খেলার সময় কে কার ভালো অ্যাভারেজ তাকে নাও টিমে, সেটা শুধু সেটা চেক করলে হবে না, কার deviation from the mean we have to check it also. For example, let us see Rohit Sharma last 3 innings score একটা 100, একটা 0, একটা 50. Okay, last 3 innings score একটা 100, একটা 0, একটা 50. And whether in the case of Rishabh Pant the score is 49, 50, 51. I think Rishabh Pant is the easier automatic selection because he is more consistent. কিছু না করলেও average 50 দেবে. But Rohit Sharma is unpredictable. Either you may get 0, you may get 100, you may get 50. So we always go for the consistent player. কিছু না কিছু result দেবে. So that is the meaning of the dispersion calculation, or the coefficient of variation calculation. Coefficient variation check whether the player is consistent or not. Okay. Now, take same type of অঙ্ক আছে দেখো. If we try to invest in, just see this first. Let us see this example. একই টাইপের কোএফিশিয়েন্ট ভেরিয়েশনের খুব সুন্দর ব্যবহার আছে এখানে। মিস্টার বাসু wants to invest rupees 10,000. 10,000 একটা লোক কোন মিউচুয়াল ফান্ড বা শেয়ার মার্কেটে 10,000 rupees ইনভেস্ট করতে চাইছে। Think of the scenario. He select two company, একটা কোম্পানি A আর কোম্পানি B, and তার শেয়ার ব্রোকার বা তার ফাইন্যান্সিয়াল অ্যাডভাইজার told him যে if he select the company A, the average return for that company A is rupees 16,000. সে কত টাকা ইনভেস্ট করতে চাইছে? 10,000 rupee he want to invest. Was his financial advisor or the share broker, যাই বলো না কেন, told him that company A, for the company A, he will get return as 16,000 average return পাবে, 10,000 টাকা দিয়ে 16,000 রিটার্ন পাবে, but with an SD of 125, that is variation, return কিন্তু পারফেক্ট 16,000 টাকাই পাবে, রিটার্ন নট নেসেসারি। এটা ব্যাংকের ফিক্সড ডিপোজিট নয়, দিস ইজ শেয়ার মার্কেট অর ইউ ক্যান টেক দ্য মিউচুয়াল ফান্ড। সো 16,000 রিটার্ন পাবে ঠিকই, বাট দ্যার ইজ এ ভ্যারিয়েশন অফ 125 rupees. But for the company B, he will get 20,000 return by investing 10,000. But there is a variation of 200 rupees. Fluctuating, high fluctuating. কোম্পানি বি রিটার্ন বেশি দিচ্ছে বাট ফ্লাকচুয়েট করছে হাই, কোম্পানি এ রিটার্ন কম দিচ্ছে, 16,000 রিটার্ন দিচ্ছে বাট ফ্লাকচুয়েটিং লো। হুইচ কোম্পানি উইল ইউ রেকমেন্ডেড টু মিস্টার বাসু ফর ইনভেস্টমেন্ট? তুমি কোন কোম্পানি মিস্টার বাসুকে রিকমেন্ড করছো? ইন দিস ক্যালকুলেশন, ইন দিস টাইপ অফ এক্সাম্পল, ইউ অলওয়েজ গো ফর সিভি ক্যালকুলেশন। দেখো সিভি বার করেছি। ফর বোথ কেসেস উই গো ফর কোএফিশিয়েন্ট ভ্যারিয়েশন ফর দ্য কোম্পানি এ, sigma by x bar into 100, and company A it is, we got sigma means 125. এই যে কোম্পানি এর সিগমা কোথায় গেল? 125 and 16,000 mean. 16,000 is arithmetic mean, sigma হচ্ছে 125 into 100, we can get this for the company B, the CV coefficient of variation 200, like this sigma, and variance arithmetic mean by average will be 20,000. We get 1 and we get point. Again, hence company A is more stable. Why more stable? Because variation is less for the company A. For the company A, CV is 0.78, but the company B, CV is 1. So company A is more consistent or stable. সেফ সাইড। টাকাটা দিচ্ছি 10,000 টাকা, টাকাটা পুরো ফুতুর হবে সেটা তো চাইছি না, আমি চাইছি মোটামুটি একটা উই ক্যান গেট সামথিং কনসিস্টেন্সি। অলদো উই ক্যান সি ফর দ্য কোম্পানি এর ইনকাম কিন্তু আউট রিটার্ন কম, 16,000 রিটার্ন, অ্যাভারেজ রিটার্ন কোম্পানি বির অ্যাভারেজ রিটার্ন 20,000, আমি ইনভেস্ট করছি কত 10,000, তাহলে আমি কোম্পানি এ কে সিলেক্ট করছি রিটার্ন কম থাকা সত্ত্বেও। ওয়াই? বিকজ কোম্পানি এ ইজ মোর স্টেবল, সেফ সাইড। দরকার নেই আমার 20,000 রিটার্নের, আমি 16,000 পাই বা তার আশেপাশে পাই। বেশি রিস্ক নিতে গেলে, বেশি রিটার্ন পেতে গেলে উই হ্যাভ টু গেট রিস্কও হাই হয়ে যাবে। ওকে, so in this type of example you always go to calculate coefficient of variation. সিবি কিন্তু খুব ইম্পর্টেন্ট, পরীক্ষায় সিবির ওপর অঙ্ক দেবে একটা, মাথায় রেখো।